Hello, we're going to briefly discuss our more advanced trigonometric function graphs using GeoGebra to give a more intuitive feel for why some of these changes work in the way that they do. So we're going to start off using our green line here with y is equal to cos x. Let's look at some of the facts we know about y is equal to cos x. We know that we're going to start off at our maximum value when theta is 0. Our function, our cosine, is 1, and then when we go down to 180 degrees or pi radians, we're down at -1. So our function is oscillating between plus and -1, as we would expect. Its middle line is just the theta axis or the x-axis. We're oscillating around that axis. We can imagine that as being the still water line, if we were thinking about this as waves of water. We have our period of 2 pi. So if we go from 0 to 2 pi, we start repeating our function. But likewise, if we started from pi over 2 and rotated through there, we would end up repeating after 2 pi as well. So the period does not have to go from 0 to 2 pi. It's just the distance between where our function starts repeating itself. Now, that's enough of a preamble of what we already know about the cosine function. What happens when we change it? So I'm going to leave the green line active, and we're going to look at what happens when we have y is equal to 2 cos x. Let's think about what we know is going to happen first. Every y value is going to get multiplied by 2. So we have the y values from our green line. If we have 2 times that, we're just going to have every y value is going to go double. It's going to get doubled. So if we were at +1, we multiply by 2, we're going to end up at +2. If we were at a half, we're going to go up to 1. All of our y outputs are going to get doubled. Nothing's going to change with our x values. It's going to oscillate just as quickly or slowly because we haven't done anything with the x input, but the y output has been doubled from where it was. So let's see what happens where we have our red line now is y is equal to 2 cos x, and we have effectively just doubled our amplitude. We have doubled our distance away from the middle line, midline, or the neutral line, when we have multiplied by 2. And if we multiply by 3, we see that we are now 3 times as far away from our midline, our x-axis or our theta axis. So we can see why it is that multiplying our oscillating function, our sine or our cosine, by a number is increasing our amplitude by that amount. We are multiplying by that amount to give our distance between the neutral line, the midline, and our maximum or our minimum. Now, that's what happens when we're multiplying by a constant, when we multiply our function by a constant. What happens when we multiply the x input or the theta input by a constant? Well, the effect of that is going to be that we're going to rotate faster. If we put in theta was 10 degrees, we'd be effectively calculating what cos of 2 by 10 is 20. So cos of 20 degrees. We would be going through our angles twice as fast. So if we turn that on, we can see that we are oscillating twice as fast. We go through a full period of the cosine function in only pi. But what happens if we divided this by 2 instead of multiplying by 2? I'm going to change that and we'll come back to you. Now we have our function and we can see that we are oscillating half as quickly. By the time we have gone through 2 pi, we've only gone halfway through our function. So if I pull this over, we might be able to see enough of it. just about, actually, there we go. So we can see that if we half our x input, we are going to, if we put in theta is 90 degrees in here, we'd effectively just be getting cos of 45 degrees. We're changing our angle half as quickly. So we are going to take twice as long to go through a full oscillation. Now they don't have to give you nice things like doubling or halving. They can give you 3/5 or something like that. And it's important that we be able to work out what the effect that period change is going to have. Now, finally, let's have a look at what happens when we combine this with adding on constants to our y value. Now, if we wanted to add on, so if we go back to having y is equal to cos x, but we've added on 4 to it, what's going to be the effect? Well, we have our green function like we did at the beginning, that's just the cos x. And if we have y is equal to cos x plus 4, every y value, every single y value on our green line is just going to have 4 added to it. So it's just going to move up by 4 places. Now let's see if that's what happens. And it is. What was at 1 goes up to 5, we've added 4 on. What was at -1 goes up to 3, we've added 4 on. What was at 0 goes up to 4, we've added 4 on. So we've just shifted our function up 4 places. And that is the effect of adding on a constant onto our function. And we can see why that is, because we've just got exactly the same shape, but we've added 4 to every single y coordinate. Now, finally, we're just going to combine this so that we have a bit of a look. If we say multiply by, we'll go to multiply by 2 because it's easier to see on our graph. So what have we done now? We've added 4 to every y output and we've multiplied this by 2. So what effect is that going to have? It means we're going to oscillate twice as quickly. So our period is going to be half of what it was. So let's see what effect that has. Well, we're up 4 places. We've moved up 4 places and we're oscillating twice as quickly. It only takes a period of pi to do a full oscillation. And then finally, if we multiply this by a number, we say multiply it by 3. What effect is that going to have? It's going to make our amplitude 3 times bigger. So let's see its effect. Our middle line is at 4 because that's what we have shifted everything up by. And then our amplitude is now 3. So we're going from 4 down to 1 and 4 up to 7 because our cosine function oscillates between plus and -1 and we're multiplying that by 3. So the maximum minimum is going to be 4 plus 3 up to 7 and 4 minus 3 down to 1. And we're oscillating twice as quickly, so we go through a full cosine period in pi degrees because we are going twice as quickly. And we know that the cosine function by itself would go through a full oscillation in 2 pi. So that's what we need in terms of our functions, and this is hopefully a more intuitive way of developing this type of general equation. And it's important we be able to read these things because exam questions have often been developed around you being able to have a visual intuition about how these functions work.